Here we have a cuboid which is 12 by 5 by 4. We want to find the distance from A to G, which is this distance across this long diagonal. In order to do this, we want to form a right-angled triangle in which the length AG exists. Such a triangle is the triangle ACG. Let's draw this out as a 2D diagram which we can understand better. Here we have A, this is C, and this is G. We know this length is 4, and we don't know any other lengths in this triangle. However, we can work out the length AC. We can form a second right-angled triangle, ABC, which we can see is right-angled at B. So let's draw this triangle. We know the right angle is at B, so we have ABC. AB is 12 centimeters long, and BC is 5 centimeters long. To work out the third side, we could use Pythagoras' theorem, or we may know that 5, 12, 13 is a right-angled triangle. We now know that AC is 13, so we can use this in the other triangle. We can now find AG using Pythagoras' theorem. AG squared is 4 squared plus 13 squared, which is 16 plus 169, which is 185. Therefore, AG is equal to the square root of 185. The important thing here is what we're going to note now. This will save us going through the whole of this process when we're working out the magnitude of a three-dimensional vector. If we want to work out the length of AG, we just take 12, 5, and 4, and calculate the square root of 12 squared plus 5 squared plus 4 squared. If we do this, we get the square root of 144 plus 25 plus 16, which is root 185, the same result. This is relevant when we want to work out the magnitude of a vector in 3 dimensions. Let's consider working out the magnitude of A, where A is the vector 12, 5, 4. If we look at our diagram, AG could represent the vector A. We want to work out the modulus of the vector, so we simply do that mod A is equal to the square root of 12 squared plus 5 squared plus 4 squared, and we know of course that this comes to root 185.